In this video, we are looking at RLC calculations for both grade 11 and grade electrical power systems. So here's the circuit given. And we have the resistance is equal to 30 ohms, L is equal to 300 millihenries, and we have XC is equal to 30,32 ohms. So do note that the capacitive reactance is given in this video. So in this question, XC is given. Also, the alternating current is noted by that symbol of the sine wave, and 80 volts is the voltage and 60 hertz is the frequency. Now the first question says calculate the capacitive reactance of the circuit. That would normally be the question, but in this case it's not asking for the capacitive reactance in the circuit. It is asking for the value of the capacitor. So do note that XC is given. The X means reactance. And so here we are going to find the C value. So finding the C value, we would have to manipulate the formula and make C subject of the formula, or you can substitute all the values first and then switch it. Okay, so notice that we have the frequency of 60 hertz, and 60 hertz will go where F is, and then C is unknown. XC is given at 30,32 ohms. Now swapping those two numbers around, we will make C subject of the formula. So in other words, swap C and XC. Then on our calculator, we will get this answer of 0,000040,87486. Now move 6 places so that you can get microfarads. That answer at the moment will be in farads. So counting 6 decimal places, moving the comma 6 places to the right, it will then become microfarads. Question 2 says calculate the inductive reactance. So the formula XL is equal to 2 times pi times F times L. F is the frequency, L is the value of the inductor. So substituting into the formula, we got 2 pi, and then substitute our frequency of 60 times the inductor, which will be 300 times 10 to the minus 3. Why 10 to the minus 3? Because it is henries, millihenries. If it was just henries, then it'll be times 300. Because it's millihenries, it'll be times 10 to the minus 3. Times 10 to the minus 3 is milli. Our answer there is XL is equal to 113,10 ohms. The next question says calculate the total impedance of the circuit. So impedance is the combined effect of resistance and reactance. So the formula is R squared plus, now you have to check whether XL or XC is larger. The larger one will come first in the brackets. In our case, XL is larger, being 113,10, and XC only being 30,32 ohms. We then substitute into the formula. R is 30, XL is 113,10, and XC is 30,32 all squared. So first we have to subtract the two numbers and then square them. Right, remember that reactance is XL minus XC. Reactance is actually X. And then we'll get the impedance on our calculator, 88,05 ohms. Looking at the fourth question, it says state whether the circuit is inductive or capacitive. So how would we know that? We'll look at the larger value. And which one is larger? In our case, it was XL. So which number is bigger? XL is bigger. So because XL is bigger, the circuit is inductive. Then our next question, calculate the power factor. So the formula for power factor is resistance over impedance, in other words R over Z, substituting our value of R as 30 and our impedance as we had calculated, which was 88,05 ohms. Notice we'll have no units because ohms over ohms will cancel. Our answer being 0.34, no units. Cos theta is 0.34 and that is the power factor. Notice we are not calculating the angle, but we are calculating power factor, which is indeed cos theta. Right, in question number 6, it says draw the phasor diagram. Remember that x is equal to xl minus xc. This means xl was larger. xl is always facing upwards. In other words, xl is on top. R will be your horizontal value. R is equal to 30 ohms. X is equal to 82,78. In other words, xl minus xc values, and then xl is equal to that. Okay, then we'll draw in the parallelogram to complete it off by drawing parallel sides. In other words, it's a rectangle, and then draw in the red line as the impedance, right? So the hypotenuse there will be the impedance. The opposite direction to xl is always xc. Obviously there's no value there, that's why I draw it in as a dash line. The dark one is going up, which is xl. Then our impedance, we said, was 88,05. Now the angle forming between there would be the phase angle, and cos theta would be r over z looking at that triangle that is drawn there. Okay, and that's how we find the phasor diagram. So in this question, they're not asking to draw the waveforms. I'm just going to elaborate. So do notice that the V will start at 0, and the current is the one that would be lagging in this case, right? So remember, with inductors, it causes the current to lag. So the current lags the voltage. By what angle? It will be the angle theta. So you could work out the angle theta by saying cos minus 1, 0.34. You should get around about, I'm not too sure, maybe 0.8 or something like that. Maybe about, sorry, not 0.8. You'll get about 80 degrees or so, 70 to 80 degrees if you work that out. And that will be how much the I is lagging the V. Okay, it'll be lagging by that amount. So let's say if it was at resonance, this means V and I would start at exactly the same point. Now the next question says, question 7, calculate the resonant frequency of the above circuit. So we have to use the formula FR, which means resonant frequency is equal to 1 over 2 pi square root LC. Notice that in the bottom, in the denominator, all that is being multiplied by each other. Then we're going to substitute into the formula our values of L, which is 300 times 10 to the minus 3, and also our C value, which we calculated above, being 87,49 times 10 to the minus 6. First, work out everything in the square root, under the square root sign. Get an answer, press equal to times pi equals times 2 equals, and then x to the minus 1 button on your calculator to give you the final answer. Right, so do note that that number that you can't see very clearly is 87,49 times 10 to the minus 6. That is the value of C, and that is minus 3 on the inductor. When we put all that in, we get an answer of 31,07 hertz. Do remember that frequency is in hertz. What does this number mean? This means this is the resonant frequency. This is where the frequency was adjusted and adjusted and adjusted until we got a resonant frequency. At this resonant frequency, we will find that XL is equal to XC. In other words, the reactances are equal. Z will also be equal to R. This means the impedance came down to the value that it now equals R. So if you go back to the phasor diagram and look at it, you'll find that your hypotenuse Z will now come all the way down and be equal to R. At this value, the current is maximum. Why will the current be maximum? Because it'll be in phase. Now, R and I are inversely proportional in Ohm's law. So this means if the resistance is at its lowest, such that the impedance is equal to the resistance, and it's at its lowest, this means the current will be at a maximum. Cos theta is also equal to 1, because if R is equal to Z And the formula for power factor is R over Z. This means you're going to get the same number over the same number, which would be 30 over 30, which would give you 1. This also means that the angle is equal to 0, the phasor angle. So cos of 0 is equal to 1. It's so simple like that. So those are the 5 things that takes place at resonance. I'll repeat. XL is equal to XC. Z is equal to R. Current is therefore maximum. Cos theta equals 1. And the phasor angle being equal to 0. So this is not too difficult to do. I do wish you well with studying. All you have to do is go through these examples that I did here, and this sets you kind of well in what you would know in answering these questions. This is RLC and also resonance frequency calculation.